So another thing we can do is combine actually multiple if statements. And nest them. So let's try this. Let's call it, oh, that's not what I wanted. I wanted to add one here. So nested if demo.py. And let's say we're going to do this. We're going to get input from user. And if input is numeric, then in here we're going to say if positive, say positive, if negative, say negative, else say 0. And then else say not numeric. And then let's put in a goodbye. And then let's do a header, display header. So we could try flowcharting this out. This is our pseudocode. And again, flowcharting is optional, but but sometimes it helps us visualize what's going on. So I'm going to make a new flowchart and put in my start. And I'm going to move this to the side because I think we're going to have multiple layers here. And so the first thing I'm going to do is display a header. And then what I'm going to do is get input. And then here I've got some decisions. The first decision is numeric. And often what we do with decisions, put a question mark next to it because it kind of makes sense. And so we're going to do something here. Just for now, we're going to say true. If it's numeric, we're going to do one thing. Otherwise, the false part of this is clearly not, just say not numeric. And then here, what are we going to do? Well, really, we actually go on to another decision, which is then we check greater than, if it's greater than 0. And if it's greater than 0, we're going to say positive. And if not, we're going to go to another check. And put less than 0. And if that's the case, then we're going to say negative. And then let's see, so this is false. And then this is true. And then here we're going to say, actually, it's not going to be one of these. It's going to be one of these because this is now an else. And here we're going to say 0. And I usually like moving that over here like this. And then let's see. So where do these end up? Well, this will drop out to a good, so what we want to have next is we want to have all of these go to this goodbye message. And I think so we'll do it this way maybe. Sometimes. And if you find this tedious to work with, sometimes just drawing it out on paper can make it easier on you. And it might be more organic and easier to think through what's going on. But then you have to erase a lot sometimes. And then this one, if it turns out it's not numeric, we're not going to do all this stuff. We're just going to display it's not numeric, and we're going to just go straight to the goodbye message. So this one I can put here, and then here, goes to the end. So that would be the flow chart for this this one. We start, display the header, get input. Is it numeric? No. We're going to say not numeric and then say goodbye. If it is numeric, then we're going to check to see if it's greater than 0, say positive, and then say goodbye. Otherwise, if it's less than 0, we're going to say negative and then say goodbye. And then else we're going to say it's obviously 0 and then say goodbye. So this is a more complex decision tree. Let's see what this looks like in code. So here we're going to say print. Hello, welcome to my program. I mean, obviously, if we're doing a real good header, we would tell more about it, but that's enough for now. And then we're going to get input from user. Same thing we've been doing, but since it can be kind of generic, I'm just going to call this variable user input because we don't know if it's a number yet. But we're going to ask them for a number. Notice I'm not converting it at this point. I'm just going to say input, please enter a number. And then we need to check if it's a numeric. Well, how do we do that? Well, what we do is we can Google and see, hey, Python, check if a number. How do we do that? Well, let's see. If we go to W3, there's a link here to W3 School. So you're going to search online for information about, if you don't know how to do it, you can use a search engine, whichever is your favorite, and you can type in Python and then just generically describe what you want and then look through the document, what documentation you come up with. W3 Schools is a good one. Often it has a lot of good information, and then we can see, oh, if I have a string here and I put is numeric, let's see what it does. Is numeric returns true if all the characters are numeric, otherwise false. Okay, well, let's say we haven't used this yet. Let's give it a try. We're going to say, let's just print initially user input dot is numeric. And let's run this a few times and try it out. So when you find a new piece of code that maybe isn't in your book and you're trying to figure out how to use it, don't write a lot of code with it initially. Just do a little print, do a little initial calculation, and let's see if I put this. Okay, it said false. That's good. And then I run it again. And then let's see. Well, maybe let's try 5.5. Ah, there's a problem there because that dot isn't numeric. Let's try running again. Let's just put a bunch of numbers. Okay, so this could work, except for it's not going to work well with decimal numbers. So there's a few other things we need to do since it won't deal with a whole number. What we might do is do this. We might first we could check to see if there's really there are two rules for a float. One is has only one decimal point, and then all remaining are numeric. So how can we count up a number of dots? So the string is a sequence, and we have a count variable. So we could say count of decimal points is equal to user input dot count of this dot. And just to try that out, we're going to print count of decimal points. So let's run that and see what happens. So we're printing out whether it is numeric, and then we're printing out the count of decimal points. And if I put 5.5, what do I get? False, but I get 1 here. Okay, so I guess I could say, well, if it's false and then 1, but that's not both of those checks. So what I could do is, it's really, this has to happen after this. So I kind of need to have 2 checks here. And so I'm going to get rid of this connection here, and I kind of need to do this really in 2 parts. And I'm going to take all of these, and I'm going to move them to the side. And maybe I can do it this way. I can say, rather than is numeric, I'm going to ask only, or less than or equal to 1 decimal points. And then if it passes that, only numbers. So if there isn't only numbers, then it's not numeric. And then we can go in and do this part. So here, how would I do that? Well, what I could do is I could say, if this, so I don't really need this variable. I could just say if the count of that is less than or equal to 1, that means I only have one decimal point. And I don't need to display that anymore. Then all this will be tabbed in. And then here I could say if, so I'm going to have to do some cleanup on this. User input, I'm going to say, let's take user input dot replace, and with the replace I could take, I'm going to take all instances of the dot and replace it with an empty string. So let's print the user input without the point and see what we got at this point. So I'm going to run that. By the way, there's an easier way of doing all this that we're going to learn later, but this is a good way of looking at some logic. So if I put 5.5, you can see I get 55. And so now, rather than checking if user input is, I'm going to check this and run that. So if that new thing I created, which doesn't have the decimal points, so you can hear 5.5 remove the decimal point, and I put in 6.7. Okay, so now it's returning true. Let's try running this again. And now I got to think through all the different possibilities. So let's put 6.7.8.9. That should not be a valid number. Yes, it didn't return that as true. So let's put in our else. Else we'll say print not numeric. So that way we have, we can see, it should say is not numeric when we do this. So now I'll put that example again, and you can see I'm testing as I'm going, and I'm trying different things out, and slowly bringing this into the behavior I want. So saying, okay, yes, put something that's not a number, that's working. Let's run it again. Let's make sure that if we put alphabetical characters in there, let's see what that does. And we'll put this in. Well, we got a false, so that's good. But so at this point then, what we can do is we can say, okay, now that we have this test, which is good, I'm going to make this into an if. If the remainder is numeric, then we're going to do all this stuff. But we're also going to need an else in here. that also says print not numeric, because this is there's now two conditions. Now this is looking kind of awkward, but and then for now, I need a statement in here so that it doesn't error out the way it is, because my if needs a statement, my else has a statement, my else has a statement. Okay, so now it should be able to tell me if it's numeric or not numeric. So we'll get that. Let's test that part out. So if I put an integer, let's see, it's numeric. Good. Let's try to shrink this up so that we can see the whole logic, hopefully. So it went through, it counted up the decimals, those were less than 1, it got down in here. In fact, let's run in debug mode and watch what it did with this. So I'm going to hit F5, pick Python. And often when you start getting into if statements and loops, running in debug mode by putting a stop point, like we showed very early on in the class, and testing your code is going to become more and more necessary. So I'm going to put a number in here, 567, and hit enter. Now, it stops here, and 567 should have less decimal points than 1. So I'm going to hit F10, and right now we're going to use step over F10. And I usually, when I see it, there's a shortcut, I will use the shortcut. So F10 got to here, and we saw we're now at 3 place. So obviously it passed this test. And if you hover over it, you see 567 obviously doesn't. And if you hover, let's see, will it give us the, sometimes you can, in some of these you can highlight the whole statement and then hover over that, and it'll give you the evaluation. It doesn't in this case. And now we are at the print user input, and we see we get the 567. So that took out all of the spaces, and then we step over one more time, and it prints out as numeric. So it successfully found in that case. So I'm going to run it again in debug mode, and this time I'm going to put in our other test case, which is I put in some characters and hit enter. And if I look at this, we step over. Okay, pass this test because there are obviously no dots or periods in here. And then we're going to check here, is numeric. We expect that, and often when you're running this, try to predict where it's going to go next. This should fail and go down to 22. And it does, because since this is all characters, it's not all numbers. It will end up here. We'll step over, and it prints out not numeric. I'm going to run one more time, and this time I'm going to try our decimal. Actually, probably need to run 2 more times to really test this out, because we need to try multiple decimal points and see that that fails. I expect it to fail here and go into this else that prints not numeric. It does do that. It does print not numeric, so that works. And then one more test to check if it picks up a floating point number. So we'll put that. This count should be 1, and so it should do okay. It does. We should now get all numbers. That should pass as numeric. It does, and then it passes as numeric. So good. We now know that this is work. And so now we can just put in pretty much the same code as we had before. And we can say if, and so let's turn it into a number. Since we know it's numeric, we'll say num is equal to the float of user input. And we're going to use the original user input because we need that decimal point in there. And then we're going to say if num is greater than 0, print positive, else, or now we do an elif, num is less than 0, print negative, else, print 0. And I've got these little red, oh, okay, because I have an extra one there. Okay, this looks like it's, so now we just, this is the same as what we did before. Oh, I've got an extra parentheses here. And I don't need these parentheses around this. I'm coming from other languages. Sometimes they use parentheses around those things. We don't need them here. For Python with if and else, we can just put our logical expression there. And so this was the same as the code we did before. Notice that as you go along and you learn different patterns, you can increase the amount of code you write at one time. You know, we did this before, so we're pretty sure this will work. And then we can test our test cases. So I'm going to use Control F5. And usually I test with Control F5 until I run into a problem, and then I'll put a stop point and go into debug mode to really check it. But let's see, I put 5.5. It's numeric and it's positive. Let's run it again. And then let's put a negative. We ran into another problem. It thinks the minus sign is not numeric. So we need to actually do the same thing with a minus sign. And so I could do that up here. I'm going to I'm going to get rid of the minus sign as well. And I need to do this here too. So I'm going to check if the user count, then we're going to do that, which means that all of this needs to be indented as well. This got much more complicated. And we will need another else as well. So we're going to make sure, again, we're going to nest again and make sure that we only have one minus sign. And there's probably things that we need to do. We need to check to make sure that this is that this only occurs at the beginning. This gets very complicated very quickly, but that will help us, I think, get through. We can just do that check, and let's try that. Please enter a number. So now let's try this. Again, we got a not numeric. And let's run in debug mode, see why this one didn't work. So I'm going to run a debug. Minus 123.45. Okay, count of those should be less than or equal to 1. So let's step over that. Okay, we're good there. We replace this. Count of minus is less than or equal to 1. Okay, we're good there. We replace that. And, oh. Okay, so the problem is that I replaced from the original, and that left the period in, and then it couldn't pass the is numeric. So notice that because I went to here, this is now 123.45. We need that to be 12345. How do we fix that? What we need to do is actually what I'm going to do is we need to be checking that, and then let's just make this be without minus, and then we'll use that here and here. So I'm going to stop, and I'm going to run again. And we'll enter a number, minus 123.45. And we'll step through. Okay, pass the first check. User input only has one of those. We'll run again. And let's see, it passed that check because there's only one minus. And then it subtracted the minus, so this is now 1, 2, 3, 4, 5. Yep. And then, is that numeric? Yes, it's numeric. And then we might as well follow through here. So now, number's been turned into a floating point number. It's not greater than 0. It is less than 0, so now it's going to print negative, and our program's done. So this now works. Now we could keep running through this and checking all kinds of use cases. There are still some other use cases where it could fail. For example, the minus could be in the wrong position, and we'd have to make sure that it was in the right position, and we could elaborate on this. Obviously, you can see that verifying that something is a number before you convert it can be pretty complex, but that's how we can use if statements and nest them together to solve a complex problem. And basically that's the programming process. Is you write a little bit of code, you test it, you try to think, how can I make this fail? You test that case, confirm it fails, and then you write a little bit of code to fix that problem, and then you fix the next problem, and you fix the next problem. And sometimes you have to go look things up. We went and saw, hey, how can I tell if something's numeric? We found something, we played around with it, and that's basically the programming process. Thank you very much.